All right, a new video. This one is all about lines. So the y equals to mx plus b form. For anyone who has studied lines, they will remember this. For anyone who's just studying it, I guess you're gonna have to learn it. So what am I gonna go over in this video? We're gonna go about, trying to identify, so the slope, and you should know what the slope is. I'm going to provide a link up above, so know what a slope is before you watch this. Identifying the y-intercept and the x-intercept from the graph. So given any of these lines, you should be able to identify the slope, the y-intercept, and the x-intercept relatively easily. And then you should be able to graph a line using the actual form of y is equal to mx plus b. So I'll show you how to do that using two intercepts, which is one of the easier methods. So if you know those, you should be able to graph a line, and then using any 2 points. And from those, we should be able to also obtain the relation of y is equal to mx plus b. So if you have been given 2 points, you should be able to transform it to the format of y is equal to mx plus b. Or if you were given the intercepts, again, you should be able to transform it to the y is equal to mx plus b. Okay, so if you're interested, continue watching. All right, let's do it. All right, so the first item, identifying your slope, your y-intercept, your x-intercept from a graph. First off, so the y-intercept and the x-intercept. So if I clean this up a little bit, so I'm going to remove, so a few things here. Let's say that we just want to keep one of these lines so that we make it relatively nice and easy. And I'm going to zoom in. So you have your y-axis. So here is your y-axis. So those are the vertical. And that is your dependent variable. And then here is your x-axis. So you have your x-axis running in this direction. And now the question is, so if you're given these two axes, you're given a line, what is an x-intercept and then what is a y-intercept? Well, a y-intercept is basically where the line crosses the y-axis. So in this instance, so what we would have is this point right there. That would be your y-intercept. And it is your y-intercept because that's where the line crosses that y-axis. Your x-intercept, well, your x-intercept would be right here, and that is where the line crosses the x-axis. So what you have right there, that would be your x-intercept. So being able to identify these from a graph should not be too difficult. Now remember that it is a point. So for example, if you're looking at the x-intercept, so that x-intercept happens at -2. So this is right here. So if you were looking at that point, so that would be -2, and then your y, is just 0. So this is your x and this is your y. If you were trying to pick off this particular point right there. And now your y-intercept, so in the case of your y-intercept, so what you would have is, so in this case, your x is equal to 0. And your y, well, in this particular example, would be 2. So again, this is your x and this is your y. And that is coming from, again, so remember, this is your origin right here. So you would have your 0 right there. So those are your x and the y-intercepts. And we should be able to pick these off from any line that is drawn. So now we have the original, 4 lines. So we have done the x and y-intercept for this. Now what would be the x and y-intercept, for example, for the B line? So here, so if we're walking through, so notice that here is your y-intercept, and then here is your x-intercept. So you have these 2 points there. So it's easy to identify them in terms of visually, and if you were trying to write it down as the coordinates, so you would have, so for example, for your x-intercept, so in this case it is 7, and then your y is 0. So that is this point right there, and the reason is, again, so notice, so we have 1, 2, 3, 4, 5, 6, and 7, and then your y is 0. And your y-intercept, so in this particular case, so what you would have, okay, so that would be this point right there, and that, okay, so here x is 0, and then your y would be 5. And I'm just looking at it, so 1, 2, 3, 4, and 5. All right, so that would be your y-intercept and your x-intercept. So that's what you have there. And now it turns out that in your y is equal to mx plus b form, so in our format of y is equal to mx plus b, so it turns out that this b right there is nothing else but just simply your y-intercept. So that's how you would actually read it off. So it's pretty nice and convenient, okay, to have that and know how to identify it. Now in the other lines, so if we take this and, for example, only concentrate on C, you notice that it is a flat line. And now this flat line only goes through your y-axis. It doesn't go through the x-axis at all because it's just simply flat. So for this, we have no x-intercept, but we do have a y-intercept, and that y-intercept is right there, and that y-intercept would be, so in this case, would be 0 minus 4. Now, the slope is 0 because it's a flat line, okay? And therefore, it's not going to cross the x anywhere. If you're looking at the D line, so in the D line, notice that the opposite happens because you have a vertical line, that in this case, there is no y-intercept. Okay, so because this particular line just goes straight through, okay, -4 on the other side, and this is only an x-intercept here, and that x-intercept would be -4, 0. Now, sometimes on occasion when you run into these, and what you may find, okay, is as you're doing these particular lines, sometimes your vertical line will actually align directly with your y-axis, right? So it falls exactly on your y-axis. So in that case, if it goes right through your y-axis, then your x-intercept would basically be 0, and your y-intercept is the entire y-axis because that's where it falls. And the same thing happens if you have a flat line, and that flat line is actually the x-axis. Okay, so then in that case, the y-intercept is 0, and you have a flat line all the way going through your x. So your x-intercept is actually the entire x line. Okay, so that's how we identify the x and the y-intercepts. Now, how do we identify the slope? Well, so as I said, so hopefully you've watched that video and you know how your slope works. Well, your slope is just your rise over run. So we can take any line that we like and identify what the rise over run is. So from those, okay, let's try to take all of these and identify what the equations or what the relationship is between y and x for all of them. All right, so let's do that. So let me bring you back. Okay, so now we have our x and y intercepts identified, and we're going to work through them just one by one. All right, so I'm going to switch now to the color kind of pink. Okay, and now for A, so remember what we want is we want to be able to put this in this format. So we need to identify what the slope is and then what the y-intercept is. Well, we already did the y-intercept, so that y-intercept for that line was here, so that was 2. So therefore we know that this will equal to a slope plus +2, and that's coming directly from that. Now my slope, which is just rise over run, so in this case what I would have is, so slope is equal to rise all over your run, and you can pick any two, okay, points on that line and then see what the rise over run is. So for example, okay, I'm going to conveniently pick this, okay, because I noticed that this particular line, okay, so goes through, okay, so -2 was my x-intercept and my y-intercept. And notice I can now do the actual slope. So my rise, so in this direction, so my rise here, let me blow this up. Okay, so this would be your rise, which is going in this direction, right there. So your rise is 2, and your run, which is going in this direction, so that would be that. And your run is also 2. So my slope, okay, turns out to be, okay, so in this case, it is 2 over 2, which is just equal to 1. So my equation would be 1x plus 2, and we don't typically write the 1, so this would be just x plus 2 as your equation, or your relationship between y and x, with slope 1 and the intercept of 2. All right, so that's the first line. Now let's try to actually do exactly the same thing with your second line. And with the b line, so here what we have, so again, I want to put it in y is equal to mx plus b. Now you will notice that the slope is negative because the steepness of the line, so it's coming down for us. So we have a negative slope, so we know that. We also know that the y-intercept, so in this case, our y-intercept is right here, and that was 5, so that's what we said. So we know that we have mx plus b, and it is 5. So we're there, and all we have to identify is the slope itself, so that would be m is equal to, and now again I can pick 2 convenient points and then see what the rise over run is. And for this case, you know, I can take again, so the 2 points which are basically the intercepts, and then see what happens. So what I have, so if I blow this up, okay, so here I'm going to go, so I'm going across all the way up to here, so that would be that. And then I can go and take this, okay, so that's coming down. So this is my run, and then this is my rise. So again, rise over run. So my rise, in this case, it's coming down, so it is negative, and we know that it would be negative because our slope, okay, is sloping in this direction, and that would be 1, 2, 3, 4, 5. So this would be negative 5 as it's coming down, and then it's running for 1, 2, 3, 4, 5, 6, 7. Okay, so that would be 7. So my overall equation, okay, now turns out to be y is equal to negative 5 over 7 x plus 5, and that would be it for your line B, okay, in this example. Now the next 2 examples, C and D, are kind of interesting. So if I'm going to remove all of this, and let me remove the line as well, so I'm kind of cleaning it up. Now for your line C, what is interesting is that here we know that the slope is 0 because it is a flat line. So we have a flat line and the slope is 0 because there is no rise, right? You're not going up and down. So for our equation, we have y is equal to 0x, and we also know, okay, our y-intercept is negative 4. Okay, so this is our equation of the line. Now, typically what will happen, people do not write 0 times x because 0 times x is nothing. So they will just simply provide this as the equation of the line, which is a little bit, sometimes it may throw people off because it doesn't look like your regular mx plus b format. And don't get caught with that. Okay, so this just simply means it is a flat line, okay, at y is equal to negative 4 if somebody gives you that relation. And what it means is for any x that you have, y is always equal to negative 4. That's what it would be. So that's line number C. Now, what about line number D? So this one is also interesting. So let me remove this, and that leaves us just this with one line. Now here we don't have a y-intercept. So when we're doing this, mx plus b, Unfortunately, we do not have this, right? Okay, so this, we don't have that because it is going through -4. We also, if you take a look in terms of your slope, so this slope right here, this is also tricky. Now, you can pick any 2 points that you like, and I just want to show you what happens, okay, with these vertical lines. So let's say I pick these 2 points. So that would be this point and this point. Now, if I wanted to do rise over run, so slope equals, so my rise in this case, so I'm rising 1, 2, 3, and 4. But my run, there is no run. It's 0 because it doesn't move anywhere in the x direction. So this, okay, is an infinite slope, okay, or it is called undefined for us. And what that means, it has a vertical line. And now we can't really put that in this y is equal to mx plus b form. So vertical lines actually don't have a y is equal to mx plus b form. And the way that we designate them is we always know that we have an x-intercept, and so we write these lines as x is equal to and whatever that x-intercept is. So it doesn't look at all like this, but that indeed is the relationship. So that means that for any y, x is always equal to -4. So those are the kind of 4 situations you may run into with positive slopes, negative slopes, okay, flat lines with 0 slope, or vertical lines. All right, so that's how we would be able to identify these particular equations. All right, now next topic. So the next item is graphing a line. So first, okay, so how would we graph a line if somebody gives us the y is equal to mx plus b form? Okay, so how do we do that? Then what if somebody gives us the intercepts themselves? You know, can we graph that through? And then finally, okay, what if somebody just gives us 2 points? So let's take a look on how we would handle those situations. Okay, so here, so we have our nice graph. So I'm going to label this. So this is my y-axis, this is my x-axis. And you can assume that one of these spaces, okay, is basically equivalent to 1. So this would be 1, 2, 3, 4, and so on. It doesn't always have to be that way, but as you are just starting on graphing these things, it's a nice introduction to that. Okay, so let me give you a few lines. So we have, so here for example, okay, let me provide you, so we have y is equal to, let's say, -x plus 3. So that is our y is equal to mx plus b form. So first, what you have to know is, from this, you have to pick out what your slope is, which is -1, and that's the number in front of the x. So in this case, it's negative. And you also have to pick off your intercept, and your intercept is 3. So the way that I like to graph these is I will always take the intercept itself. So because I know that that is the y-intercept, so for instance, what I would do is I would graph here my first point, okay, which is right there. So that would be 3. And now I will be using, okay, my slope. So my slope is -1. Now, whenever you have a slope, okay, so remember that -1 is equal to exactly -1 over 1. Now, the reason why I write it as a fraction is so that I have my rise over my run. And so what I will do is I will start from this point right here, so from my intercept, and I will use the slope, so the rise of -1, which means coming down 1, and then the run of 1, which would be positive. So in this case, what I would do is I would bring this down, okay, so this would come down right here, so that would be your rise of -1, and then your run is of 1, so this would be your second point. All right, so that's what you have. And now because you have 2 points, if you have 2 points, you just draw a line through it and you've graphed your line. Now you can put more points if you like, so you can continue this. So notice from here, because again, rise over run is -1 over 1, so here's another point, okay, and again, rise over run, here's another point, and I mean, you can continue this and draw as many points as you like from the slope, but 2 is enough. So what you would have here is now you can just draw your line. So I'm going to try to draw it, okay, within here. Let's shift this over so that it crosses through. All right, and there is your line. Now you can label it. So sometimes teachers like to see that you've labeled it. So this would be y is equal to -x plus 3. And that's how you actually graph these lines. Okay, let's do another example. So here, let me give you, let's say y. So we had a negative slope, so let's make this slope positive. So for instance, let's make it 4, okay, over 5x. And let's make the intercept negative, so -2. So again, what we do is we will take first our intercept. Now notice it's negative. So we will take it and bring it down. So negative is right here. So that's -2 right there. And now we will use our slope. So here's our slope. So we have a rise and a run. So they're both positive. So you can take, okay, so your rise, so it's going to be rising 4 and running 5. So notice 1, 2, 3, 4, and then running for 5. 1, 2, 3, 4, 5. So your next point is right here. Now you have your 2 points, and you can draw your line directly through those points. Okay, so we would have something of this nature. Okay, and that would be our line if you wanted to do that. And of course, you can label this and you're finished. That is it. So you always start again from your intercept and then use your rise over run to get the graph. So that's how you would do it. Now, one thing is, okay, so remember what we talked about is if you are given, okay, for instance, something like this, and to you it seems like, oh, there is no slope, don't forget, okay, that y is equal to some number means that it is a flat line. This doesn't mean that there's no slope. It means that the slope is 0. So you have y is equal to 0x plus 5. That's what this actually equals, except we don't really write because 0 times x is just nothing. So if you were graphing this, okay, so your intercept would have been, so 1, 2, 3, 4, 5, so it would have been here, and this line is basically a flat line. So that's how it would look like. And again, the same thing would happen if you had, okay, let's say x is equal to -1. So in this case, it's a vertical line. All right, so where you're finding your x, so here in this case, what you would have, so x -1 would be right here, and this would be a vertical line going right through, okay, that -1. Now you can draw the arrows if you like because they are lines. So there you have it. So that was using y is equal to mx plus b to actually graph a line. Now, what if you're given intercepts? What if somebody tells you what the intercepts are? All right, so great. So if we are given intercepts, so let's say, let me put this here, and somebody comes along and says, well, your x-intercept, all right, let's say is, okay, -2, and your y-intercept is, let's say, 5. So that's what you have. Now, they might give this to you as actual coordinate system pair, so basically a point. So x-intercept would have been -2, 0, because that's where it crosses the x-axis. So in this case, it would have been right here. And then this, okay, would have been 0. So for x-intercept and y-intercept would have been 0, 5. And that would have been 1, 2, 3, 4, and 5. So that would have been there. Now again, because you have 2 points, then from those 2 points, you can just go ahead and graph your line. So we have, okay, so these are my 2 points, okay, and now we can graph this line. Sorry, I'm going to just extend this so you can see that it is kind of a line. And there you have it. So it's actually very simple if you're given the x and the y intercepts. Now, the trick is, what if you wanted to know what the actual form is? So if you wanted to put it in this form, then how would you do it? So you have to now think back, well, what do I need? I need the slope and I need the y-intercept. The y-intercept is easy. I already know b because they tell me what b is. So b is right here. That's what I have there. All right. Now, what about the slope? So the slope is also not bad because just as we did in the previous examples, this, all it is you just have to know your rise over run. So my rise, so going in this direction, okay, and then my run, which is going up in this direction, so that would be that. So this is my rise, and this is my run. And all you have to do is, if you have the x and y intercept, you know your rise is 5, and then your run, in this case it's positive, notice, so it would have been 2. So your slope is 5 over 2. And therefore that makes the equation y is equal to 5 over 2 x plus 5. And there you have it. So if you're given x and the y intercepts, then trying to graph them is basically plotting your points and then drawing a line. And trying to get the actual equation out, okay, from this line, just simply look at your rise over your run between those 2 points that you've plotted, and you have your answer. All right. Now, the last thing that can happen is, what if somebody gives you 2 points? But this process is identical. It's exactly the same as the x and the y-intercept because those are 2 points. So if someone gives you 2 arbitrary points somewhere, then you definitely can plot the line. Let's try it. So here, what we have, so if I give you the graph again, and I arbitrarily put in 2 points somewhere along here. So let's say here is 1 point, and let's say that my other point, okay, was somewhere over here. All right, so those are my 2 points. Now, it's not going to be fun in doing this because it may not exactly cross the x and the y axes where I want, but okay, I can definitely draw the line. So I would draw this line, okay, connecting these 2 points. All right, so that's what you would have. Now, I'm going to extend this here. Okay, and then I'll extend the line here as well. And so those are my 2 points. Now, I have picked them arbitrarily. Now, what are these 2 points? So let me maybe put that in there. So my points are, so this would have been, okay, so -1, -2, -3, -4, -5. So this point right here is -5, and that would have been 1, 2, 3. All right, so that's my point there. And here, my point is 1, 2, 3, 4, 5. And -1, 2, -2. So those were the 2 points. So if someone gives you those 2 points, you have to be able to plot them. And now you can draw the line through it. And you're done. Now, what if you had to create y is equal to mx plus b from this information? So not as easy, right? Because we need our y-intercept. So our y-intercept is here. And notice it doesn't exactly nicely align with the crossing at a particular point. So it looks like it's between 0 and 1. It's kind of halfway. So there is a little bit of guessing here that you have, right? Okay, if you were trying to read this off from the graph, you know, so you can say it's kind of halfway, so 0.5 is my b, Now my slope is a lot easier to get because my slope, all I have to do again is to get the rise over the run. So remember that what you're doing with that is, so here is your run, so from here to here, and then your rise would have been from here to here. And you can count, okay, your rise over run. So that one is much easier. So my rise, and notice it's a negative slope because it's going in this direction. So my rise is 1, 2, 3, 4, 5, and it's negative 5. It's falling down. So from my slope, that's that. My run, what I have, okay, is in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that is just equal to, if you simplify this, to negative 1 over 2. Now, for those who've watched the slope video that I introduced in the beginning of this particular video that you're watching now, you actually don't have to do any rise over run. Don't forget that your slope, if you have 2 points, remember the equation for the slope was this. Okay? That is your general equation for the slope. So you can take your 2 points, substitute them in, and you will get your slope of negative 1/2. You don't have to necessarily read it from the graph. So that's how you have your slope. Now, once we have our slope, so y is equal to negative 1 over 2x plus b. Now remember, if we're looking at the graph, then we're just guessing our b, because we can't know it exactly where it crosses. Now, how could you possibly get the b exactly? How can you get this b exactly? What could you do? Remember, you have 2 points. So what could you have done? Well, what you can do is you can take one of those points because the line goes through it and now substitute it into this equation. So notice, here is your y, here is your x. We have 2 points. Those points are negative 5 and 3 and 5 and negative 2. Which point you choose is up to you. So let's choose one of them. So 5 and negative 2. So I'm going to choose 5 and negative 2. So again, that's your x and your y. And let's substitute it into the equation and solve for b. So this is negative 2 equals, notice, negative 1/2, and then your x is 5 plus b. So now solving this, so negative 2 is equal to negative 5 over 2 plus b. Okay, so solving this equation, if you bring this over to the other side, you're going to get negative 2 plus 5 over 2 is equal to b. And 5 over 2 is 2.5, right? So it's 2.5. So when you do this right here, okay, this is just going to give you 1/2. So this is 1/2, and that was your b, or 0.5. And now we actually guessed that from the graph, but it's not always as easy to see. And you don't want to be guessing, so what you do is you just substitute it and then solve for b. All right? So if you're given 2 points, okay, the process is, number 1, okay, find your slope, okay, using your formula. So that's what you should do, so that you're not guessing. And number 2, okay, you use y is equal to mx plus b. Take one of the points, substitute it for y and for x once you have the slope, and then you can solve for b. And you will obtain your overall equation. And in this case, the overall equation is y is equal to, and that was negative 1 over 2x plus 1/2. That was your equation. All right. So out of curiosity, you can put it in the notes. What if I gave you these 2 points, negative 1, 5, and the other point was 2, 6. Try to find the slope. Try to find the y-intercept. I encourage you to do that. And try to get your relation formula. All right. Thanks for watching. Okay, see you in a future video. More to come on lines. Bye, everybody.